Use the Newton's method to solve the equation e to the negative x equals natural log x correct to 5 decimal places. The Newton's method formula as xn plus 1 equals xn minus the function at xn divided by the derivative at xn for n equals 0, 1, 2, 3, and so forth. The function f of x in this case is e to the negative x minus natural log x, since we are going to find the root or the x-intercept where the function equals 0. We're going to need a prime, which is negative e to the negative x minus 1 over x, and also the initial approximation or initial guess, x0. The problem does not provide the x0 for us, so we're going to test the point. For example, at x equals 1, the function at 1 is e to the negative 1 minus natural log 1. We get 0, 0.367879, and so forth. For x equals 2, the function at 2 equals e to the negative second minus natural log 2, or as the approximate value as negative 0.557812, or we can use the graph to see. As we see the two function values, one is positive, the other one is negative, and the function is continuous between 1 and 2. That means the graph will pass the point where the function is 0, where the point is between 1 and 2. For our convenience, we're going to choose the initial guess x0 as the value 1. As x0 equals 1, the function at 1 equals 0.36788 as we keep it 5 decimal places. And the function f prime at 1 equals negative 1.36788. Find the x1 or the next approximation as using x0, the function at x0, and the derivative at x0. Give us the value x1 as 1.26894. x1 equals 1.26894. For the function value at x1, which is 0.4295, and the f prime at x1 equals negative 1.06919. And again, use x1, fx1, f prime x1 to find x2 using the Newton's method formula. And we get x2 equals 1.30911, and repeat the same process. Now x2 is 1.30911. The f at x2 is 0.00071. The f prime at x2 is negative 1.03394. And then use x2, fx2, f prime x2 to find x3. We get x3 equals 1.30980. So far, we have the first 3 digits the same, and we just keep repeating the same process until we get the two approximations the same number. As you see on the table, the first approximation, the x0 equals 1, and x1 equals 1.26894, x2 equals 1.30911, x3 equals 1.30980. When we obtain x4 as 1.30980, we have the same value of the two approximations, so we stop the process at this step. We verify with the graph. The graph is the graph of the e to the negative x minus natural log x, the intercept is at 1.31, which is close to the approximate that we got from using the Newton's method.